Good evening, guys. Welcome to the session. So, as we know, we are doing robotics analytics from domain, so which is done by 360DigiTMG. So, today's topic we are going to discuss about K. Okay, so we are going to see what all the steps we are going to implement. So, what were the codes we are going to see for K, and we are going to understand what is meant by K. Okay, so today's session is all about KNN, guys. We are going to go with theoretical as well as practical too. So this is day 4. We're going to see domain analytics and robotics analytics by 360DigiTMG. Okay, so let's start the session, guys. So as we know, we are discussing about the past 3 days. We have seen what is meant by CRISP-MLQ, what is meant by the agendas, what we have to follow, and what all the ED and pre-processing steps, right? So today we are going to see about what is meant by classification and how we are going to implement in the robotic analytics. Okay, so we are going to understand what is meant by KNN as well as what all the code or what all techniques we have to implement to get our desired result, right? So today we are going to see about that. So let's move on, guys. So we are going to see our agenda first. So what is our agenda? Our agenda is nothing but we are going to see what is meant by nearest neighbor classifier and what is meant by one nearest neighbor classifier and what is meant by k nearest neighbor classifier. And we're going to see what is meant by controlling complexity and what is meant by Euclidean distance. Okay, these are all the agendas for our KNN. So we are going to see step by step what we have to learn about KNN and how to implement all that. Okay, so moving on, we are going to see what is meant by nearest neighbor classifier, right? Nearest neighbor classifier. So, okay. So nearest neighbor classifier. So what is its definition means? It's going to say nearest neighbor. The name itself indicates nearest neighbor classifier. So this nearest neighbor classification is a machine learning method, guys. Okay, this is a machine learning method. Okay, that aims at labeling previously unseen query objects, like by distinguishing between two or more destination classes. Okay, this k nearest neighbor classifier is nothing but is a machine learning method that aims at labeling previously unseen query, okay, while distinguishing two or more destination classes. Okay, as any classifier in general, guys, this is the things we are going to follow. Okay, it requires some training data with given labels and thus is an instance of supervised learning. Okay, so this why we are using this k nearest neighbor, k nearest neighbor classifier. Okay, so this k nearest neighbor classifier is one of many supervised learning algorithms used in data mining of machine learning. Okay, it is a classifier algorithm where the learning is based on how similar is the data from other. Okay, so this is the definition of nearest neighbor classifier. So what is the algorithm? If you're going to ask me about this k nearest neighbor algorithm, the k nearest neighbor algorithm is also known as KNN or k dash hyphen NNS. K nearest neighbor, okay, is a non-parametric supervised learning classifier which uses proximity to make classifications or prediction about the grouping of individual data point. It's nothing but is also called as KNN, guys. Is a non-parametric supervised learning classifier or prediction of grouping in individual data point. Prediction of grouping, guys. The name itself says prediction of grouping. KN is nothing but grouping classifier. We're going to classify the data. Okay, so this is all about this algorithm and k nearest neighbor classifier. So let's move on. We're going to see what is meant by one nearest neighbor classifier, right? We have seen what is meant by nearest neighbor classifier, and the next one we're going to see is what is meant by one nearest neighbor classifier. So this is a KNN is one of the oldest methods. Okay, this is one of the oldest methods known. So the idea of this extremely simple. It's we are going to classify X and find the nearest neighbor among them, and we're going to go for training points as well as we're going to assign the label to what is a good method among them. We're going to see about that also. So we are going to see what is meant by k nearest neighbor classifier. It is nothing but where we are going to match which is the data points near to us. Okay, so this is all about this k nearest neighbor classifier, and we are going to move what is meant by Euclidean distance. So Euclidean distance is nothing but between centroid value and observed value. Don't have to stress, guys. I'm going to explain this controlling complexity in KNN in upcoming slides. Okay, what is this Euclidean distance? Euclidean distance is nothing but between observed value and centroid value. Okay, so what are the formulas we are going to use for this Euclidean distance? Right. So Euclidean distance, as I said, guys, it is a mathematics function between centroid value and observed value. You can say between 2 points in Euclidean spaces in the length of a line segment between 2 points. Okay. So for the formula for this Euclidean distance is d of PQ is equal to summation of square root of summation n I of 1 and qi of ei square. So this is the formula for Euclidean distance. So if you want to explain the terminologies for this, P and Q stands for 2 points in Euclidean distance n space. Okay, 2 points in Euclidean distance n space. So this is what is the terminologies for P and Q, and we're going to see what is the n. N is nothing but n space. So we are going to cover what all the things we are going to use in this K and N. Okay. So this was all about the agenda, guys. So we are going to move on. We are going to go for project management methodology. So what is this project management methodology? It is standard form to complete the project, right? It is standard form to complete the project. This is standard form to complete the project. To complete the project in standard form, we have 6 steps. So that is business and data understanding, data preparation, model building and tuning, model evaluation, deployment, monitoring and maintenance. So in the recent class, we have seen what is meant by this business and data understanding. What is data preparation? What are the types of that? How we are going to build the model? How we are going to tune the model, right? We have seen what is the definition of model evaluation, deployment, monitoring and maintenance. We have seen all this, right? So these are the 6 phases, guys, of this project management methodology, where we are going to complete our project standard form. So business and data understanding, we are going to get the data. Okay. After that, we are going to understand what all the problems we have to fix, and we're going to understand the data. After understanding the data, we are going to use some terminology. We are going to use some data pre-processing and EDA process, where we're going to use typecasting, monotone encoding, and we're going to use how to handle duplicates, right? We are going to use the pre-processing techniques to follow the data preparation. And we're going to build the model. So before building the model, we have seen test and train data, right? We have seen test and train data, where we're going to split our data, okay, testing to train, and we're going to calculate the accuracy in that. So if we have high and high, it's a right fit model. If both train and test is low, it is called as underfit or bias, right? Bias or underfitting. To solve this, what are the techniques we are going to use? We have seen that. And if train is high and test is low, we are going to go for overfitting or variance. So these are the things we are going to see, and how to solve this we are going to see. So what are the techniques needed to solve this overfitting and variance? So what are the technique used to solve this bias? And model evaluation. What is model evaluation? How we are going to see the model, what type of accuracy it is giving. And we are going to go for deployment. So what is meant by this deployment? How we are going to deploy the model? Are we going to deploy the model without seeing the accuracy? Or we are going to see the accuracy to deploy the model, right? We are going to see what all the accuracy it's giving. So if I'm going to get sent 80% to training data and 20% to the testing data, it's going to give us the perfect accuracy which we need, or it's going to throw some error, or the accuracy is not good. So how to increase the accuracy? We're going to see what are the techniques we are going to use, and monitoring and maintenance, of course. After deploying the model, we have monitoring and maintenance. So we can't just say we have deployed the model, right? And monitoring and maintenance, we are going to see how to deploy that. So we're going to maintain the model. We're going to maintain the accuracy of that. Okay, we're going to maintain the accuracy. So this was all about the agenda, guys. Okay, so we'll move on. So moving on, we are going to see what is meant by supervised learning. Okay, so what is meant by supervised learning? Supervised learning is a type of machine learning. Okay. supervised learning is a type of machine learning in which machines are trained using well-labeled training data. Okay, so supervised learning is nothing but supervised machine learning, you can say. It is subcategory of machine learning and artificial intelligence. Okay, it is subcategory of machine learning and artificial intelligence. Basically, it is defined by its use of labeled data sets. We are going to use labeled data sets. Okay, and we are gonna train these algorithms that classify data or predict outcomes accurately. Okay, so this is what is meant by supervised learning, guys. So what is this supervised learning algorithm? A supervised learning algorithm takes a known set of input data and known responses to the data and forms a model which generate reasonable predictions. Okay, which is going to give us reasonable predictions for the response of new input data. We are going to use this supervised learning if we have any existing data for the output, and we're going to trying to predict the output, guys. Okay. So basically, as I said, we are going to use supervised learning if we have existing data for the output, and we are trying to predict. Okay. This is the algorithm of supervised learning, guys. And why it is called as supervised learning? Because algorithms that learn from training data set can be thought of as a guide of supervised learning process. Okay. So here you can see we have training and validation. So we have seen, right, what is meant by validation. It is a third-party model which is used to avoid information leakage. Okay, it acts as hyperparameter tuning also to avoid information leakage. This is the main thing. We are going to use validation, and it is all like hyperparameter tuning too. So here you can see we are going to give a historical data, and we're going to do random sampling. So what is meant by this random sampling? So random sampling is nothing but we are going to take the data. Okay, random sampling is nothing but subset of individuals chosen from a larger set, in which subset of individuals are chosen random. Okay, which are chosen randomly. It's all the same probability, as you can give same probability. It is chosen random, same probability. It is a process of selecting a simple in a random way. It's going to select randomly, guys. There is historical data, have 10,000 data, and it's going to select random data which they need. Okay, which data is included here? It's going to take random, and we're going to send it to the training data set. And we know there is a training data set and test data set. We are going to see that what all the accuracy we need. So training data, let me say, we're going to send 80%, and 20% it's going to go for here, right? Training data, I'm going to send 80%, and it's going to do some machine learning, and it's going to give some mathematical equation and prediction and validation. But if I say 20%, this testing data set is not giving proper. So at that time, I'm going to use k-fold cross validation. Okay, I'm going to use k-fold validation. So in the code, we are going to see why we are going to use this k-fold cross validation. Okay. So this was all about supervised learning, guys. So we have seen what is supervised learning. So what is the importance of that, and what is the algorithm of this supervised learning. So after that, we'll move on. We're going to see what is the nearest neighbor. See here, what is the nearest neighbor? For 3, the nearest neighbor is 4. Right? So here you can see training examples, some for each classes. So what is the nearest neighbor? What class to assign this 4? Here you can see 1, 1, 1 and 2, 2, 2. So how we are going to assign this? So what class we are going to assign this 4 to? So let me explain you this. The next slide. You can see nearest neighbor classifier. How to calculate this nearest neighbor classifier? Here you can see, look at the data, guys. The name itself says look at the data and calculate the distance. After calculating the distance, find your nearest neighbors and vote on labels. So for you to understand it more easily, let me give you an example. Okay, the nearest neighbor. Okay, so let me say there is your one here it is you. Okay, and one of your friend is here in 20 kilometer near, and one more friend is here is like 100 kilometers. Okay, So if you want to ask a help, both are your best friends, and you want to ask any help. So which is the thing you're gonna go? You're gonna go for 100 kilometer or 20 kilometers, right? We have to see which is the nearest neighbor friends we have here. The same thing, guys. Just to understand, to make you understand about the concept, I have given this example. Don't take it too deeply. So here you can see the distance between this friend and this friend is to only 20 kilometers, right? But the distance between this guy and your friend is 100 kilometers. So which one is you are gonna refer where you can travel easily 20 kilometers, right? So basically the same thing is happening in nearest neighbor classifier, guys. We can see we're going to classify the gray point into a class here. So we're going to classify this gray point into a class here. So in order to this classifier into a gray point into a class. There are three potential. You can see here it is orange and green, and we have yellow color, which is called as lime green. Okay, so we're going to calculate the distance from this guys. So let me explain you once again. We are going to classify the gray point into a class. We are going to take this gray point into a class. Okay. After taking this, we are going to give three potentials. We have orange, we have green, and we have light green. Okay. So taking this gray point as classes, we are going to calculate the distance between them. Here you can see we're going to calculate the distance, which is the nearest neighborhood. So here you can see distance between this green and this gray color is 3.1. And the distance between this orange and this is 4.5. And distance between the lime green is 2.1. Okay. So these are the distances we have, guys. So basically, we are going to take the gray as the gray point as a class. And we're going to calculate the distance between them. So after that, finding the distances, we're going to go for finding the neighbors. Here you can see the distance between the lime green and the gray is 2.1. It's nothing but as first NN. Okay. And the next one is 2.4, 3.1, and 4.5. So next, we are going to find the nearest neighbors by ranking points by increasing the distance. The nearest neighbors, the NN is nothing but nearest neighbors. Okay. The gray points are one of the closest in the data space. So which one is the closest for this? This gray is closest for this lime green. We're going to class this win and we're going to vote this. Okay. Therefore, the gray color is nearest to the lime green. Okay. So this is how we are going to see this nearest neighbor classifier is. Basically, it's going to take the classifier which is very near to it. Okay, so how this k nearest neighbor classifier works? So the KNN working can be explained on the basis of below algorithm. So these algorithms are needed to explain this KNN working. So we're going to select the number of k neighbors. First thing, the first step. So the KNN working, how to explain this KNN working can be explained on the basis of below algorithm. Below this algorithm, we can explain the working of KNN. So please follow that. The steps we have is select the number of k neighbors. We are going to select the number of k neighbors. I'm going to show you how in the code type, guys, the practical thing, the spider. We are going to calculate the Euclidean distance of k number of neighbors. What is this Euclidean distance? This Euclidean distance is nothing but between observed value and centroid value, the distance between them. And we are going to take the nearest neighbors as per the calculated Euclidean distance. So as we know, Euclidean distance is nothing but between observed value and centroid value. We are going to take this nearest neighbors by calculating this Euclidean distance. Among these k neighbors, count the number of data points in each category. Yes. So after taking these neighbors, after calculating this Euclidean distance by k nearest neighbors, we are going to count the number of data points in each category. So to get the data, we should calculate that, right? And after that, we are going to assign the new data point to that category, which neighbor is maximum, where we are going to give the new data points to the category for which the number of neighbor is maximum. At last, our model is ready. So these are the 6 steps you should follow, guys. These 6 steps are very important while you're going to work on KNN, and I have explained you and what are the algorithms we are going to use. You are aware of that. We are going to select the number of k neighbors. And after that, we are going to calculate the Euclidean distance of k number. And taking this k nearest neighbors as per calculated Euclidean distance, we are going to take the neighbors and we are going to count the number of data points in each category, which was calculated by Euclidean distance. And we are going to assign the new data points. To which category? The category for which number of neighbor is maximum. After that, our model is ready. So these are the 6 steps which you have to follow for KN. Okay. So we'll be moving on. So we're going to see how to select K value. So selecting K value. So how to select this K value? What are the algorithms? So while choosing K value, we're going to keep following things in mind. So how to select this K value? What are the importance we should give? What are the things we should basically focus on? Okay. So we should basically focus on, if K is 1, the classes are divided into regions and the query record belongs to a class according to region it lies in. So if my K is 1, what is the thing we have to follow? What is the step I have to follow? If K is 1, the classes are divided into regions and the query belongs to a class according to region it lies in. So basically, we're going to choose odd values of K for 2 as a problem. So if K is 1, we have seen, so the regions belongs to the region where it lies in. And if we're going to odd values of K, we're going to go for 2 class problem. And K must not be a multiple of number of classes K. K is not equal to Ni, where N is nothing but number of classes, guys, and I is 1, 2, 3. So here they have explained it, where N is the number of classes and I is 1, 2, 3. Okay. So when you're going to select the K value, it is very important that you should follow the steps and keep in mind what you're going to implement and what all the steps should be taken care of. If K is 1, the classes are divided into regions and the query record belongs to a class according to the region lies in. And we're going to choose odd values of K for 2 as a class problem. And K must not be a multiple of the number and it is not equal to Ni, where N is the number of classes and I is 1, 2, 3. Okay, I assume that is clear for you why we are going to select the K value, what all the steps we have to keep in mind. So, Javier, let me explain you about nearest neighbor classifier. So what is this nearest neighbor classifier? So here you can see we are going to take this as a class. Okay, I'm going to take this the rectangle shape as a class, and here you can see there is a circle. Inside that in the circle we have rectangular round shape. So what is that? So it is nothing, guys. Here you can see the nearest neighbor for this class is nothing but this point, this data point. But here you can see this data point and this data point is far right than compared to this data point. So which is the nearest neighbor? The name itself indicates nearest neighbor classifier. So this is the nearest neighbor and remaining are far from. Okay. So as we know, we have this nearest neighbor classifier. So let me show you one more demo. So here you can see the next thing, the data point of this nearest neighbor, the rectangular shape has been taken this class, this data point. This class has taken this data point, which is near to this class. Okay. The nearest neighbor classifier is nothing but, guys, it's going to take the values which are nearer to them. Okay. So while moving on, you can see we have the nearest neighbor, the next. So it's basically going to take which all the data points which are nearer to it by using this class. Okay. So you can see the data set is increasing. For this is for 8, guys. This is for 3. So let me explain. Here you can see which is the one nearest neighbor classifier. The one data point which is nearer to it. It is that one. So the 2, it is here. 3, it is here. So for the 8 nearest neighbor classifier, we're not going to go for 4. Here you can see 8 nearest neighbor classifier. 8. You can count 1, 2, 3, 4, 5, 6, 7, 8. The 8 nearest neighbor classifier, according to this class, it has been taken. Okay. The data points, it has been taken, which is the nearest neighbor classifier. So it basically depends on how much classifier we need, guys. Okay. So moving on, we are going to see how to control complexity of this KNN. So if we have right level of model complexity, the training set accuracy is going to be high. The value validation is going to set to the accuracy. Okay. Controlling complexity of KNN is nothing but where we are going to increase our training set accuracy and we are going to decrease validation set accuracy. So why we are going to do that? So when I said k-fold cross validation, right? So I'm going to explain you this also, how we are going to implement that. And we're going to see the sample data. We're going to explain you some example. We can see in the ingredient, sweetness, crunchiness, and food type. So apple is an ingredient, guys, and bacon too. Apple is an ingredient where sweetness is 10 for it, and the crunchiness is 9. So what is the food type of that? It's fruit, right? Apple is a fruit. And if you go for banana, the sweet is more, but the crunchiness is less, right? So you can consider like this: apple has more crunchiness, banana has less crunchiness. And what is the food type of that? The food type of that is fruit. Okay, so this is the sample data. So we can see cheese, the sweetness is 1 and the crunchiness is also 1. So we can compare it, right? There is no crunchiness in cheese. Okay, and carrot, we have too much crunchiness. You can see the crunchiness is 10 and celery, the crunchiness is 10, right? Depends upon what sweetness we have, what crunchiness we have. Okay. So using this sample data, I'm going to see which is the nearest neighbor. Okay, so let me check or let me show you. The apple has 10 crunchiness of 9 and the carrot has 10. So apple, the nearest neighbor we can take for the crunchiness is carrot, right? Then we can go for pear for the crunchiness. So basically we are going to take which has the nearest neighbor. How sweet the food states. Here you can see how much is the food state. The pear is standing in first in the time of sweet, okay? And the crunchiness, it's going to go for lettuce, celery, carrot, okay? So moving on, we're going to see how crunchy the food is. So we're going to segregate the data, which is vegetables, which are fruits, and which are protein in shape, which are in proteins. Okay. So vegetables, we have celery, carrot, cucumber, and green bean. And fruits, we have apple, pear, grape, orange, and banana. So we are going to see how sweet the food states in classification of proteins, in classification of vegetables, in group of fruits. We are going to see which is has too much of sweetness, which has too much of crunchiness. So moving on, we are going to see how this tomato is being given to all. You can see the tomato has been given for nuts, green bean, grape, and orange. So it is considered as being fruits also, vegetables also, and it has proteins also. Right? We know that this tomato has everything. It is sweet, it is crunchiness, and it's gonna give us protein too. Okay, so let me explain you more further about this. We can see measuring similarity in the distance. How to measure the similarity in the distance? So locating the tomato's nearest neighbor requires a distance function. So how to calculate the distance which is required for nearest neighbor function? So we are going to locate the tomatoes nearest neighbors. We have distance function and we are going to use a formula that measures the similarity between two instances. And there are many different ways to calculate distance, guys. In that we have seen is Euclidean distance, where we are going to measure between centroid value and observed value. Traditionally, the KNN algorithm uses Euclidean distance, which is a distance one would measure if it is possible, and we are going to connect 2 points. Okay, we are going to connect 2 points. Illustrated by the previous thing, we have seen the dotted lines. So let me show you. So here you can see the tomato, which has distance, and how we are going to calculate that. Okay. So I have explained you what is meant by Euclidean distance. See, Euclidean distance is specified with the following formula. Distance of P of Q is equal to square root of P1 square plus P2 square and so on. So what is P and Q? We have seen P and Q are the examples to be compared, each having n features. The third P1 refers to value of the first feature and Q1 refers to the value of feature is an example of Q. So we are basically going to see what is a Euclidean distance we have. Okay, what is a Euclidean distance we need for this distance formula, Euclidean distance formula. Okay, so let's move on. We are going to see what is the application of Kn. So as we have seen the example of tomato, which class this tomato can belong? Which class tomato belongs to the given features? We can see tomato has sweetness of 6 and crunchiness of 4. How did we calculate that? We calculated that by using Euclidean distance. Okay, between observed value and centroid value. We have so many formulas, guys, but we have used Euclidean distance how to calculate that. Okay, and the result we have got is sweetness is 6 and crunchiness is 4. So what are the advantages and disadvantages of Kn? So advantages of using Kn algorithm. No training phase is required for that. So the Kn algorithm, no training phase is required. It can learn complex models easily and is a robust to noisy training data. Okay. So the advantages of using Kn algorithm is no training phase is required and it can learn complex models easily and it is robust, it is nothing but a noisy data. So disadvantages of using Kn. What is the disadvantages of using Kn algorithm? Determining the value of parameter can be difficult as K values can give different results. So disadvantages of using Kn algorithm. While we are going to determine the value of parameter K, it can be difficult for us to see different K values which has given different results. And it is hard to apply on high dimensional data. So when we have high dimensional data, it's hard to apply. And the computation cost is high. Of course, it is hard to apply in high dimensional data, the computation cost will be high. Okay. And each query it has to go through all records, which take 0 to the n time, where n is nothing but number of records. If you maintain a priority, we are going to get to the closest of k records, and the complexity will be 0 to the log of k star. I'm going to show it in the coding part, guys. So what is the use case and what is the graph I have got using this robotics analytics? I'm going to explain the course. This is the normal graph we have got for mean of variables of each group, guys. Here you can see orientations and angular velocities and linear accelerations. This is the graph for the user case. And we're going to see what is meant by this genetic algorithm. So genetic algorithm is a method for solving both constrained and unconstrained optimization, which is a problem that is based on natural selection, the process that drives biological evolution. We are seeing what is genetic algorithm. The name itself says genetic. Genetic means you should go for biology things, right? The genetic algorithm is a method of solving both constrained and unconstrained optimization. That the problem is based on natural selection and the process that drives biological evolution. So genetic algorithm repeatedly modifies a population of individual solutions. It's going to modify a population of individual solution. At each step of the genetic algorithm, we are going to select individuals from the current population to be parents and uses them to produce the children for next generation. So this genetic algorithm, you can see the flow chart. You can see create initial population. We're going to score and scale population. We are going to retain elite, and after that we're going to select parents, and we're going to produce crossover and mutation of children. So genetic algorithm is nothing but where we have a method of following both constrained and unconstrained optimization, and the problem that is based on natural selection. So we have seen the flow chart for that also. So we'll be moving on. You can see what is genetic algorithm and what is classical algorithm. So classical algorithm, it's going to generate a single point at each iteration. Genetic algorithm generates a population of points at each iteration. We are going to select the next point in classical algorithm by deterministic computation, and we are going to typically converge as quickly as local solution. And in genetic algorithm, we are going to typically take many functions evaluation to converge, may or may not converge at local or global minimum. Okay, so we are going to use this classical and genetic algorithm for these purposes. So what is greedy algorithm? We have seen what is genetic algorithm and everything. We are going to see what is meant by this genetic algorithm. So genetic algorithm is nothing but guys. Over let me say the population evolves. Right, there was a dinosaur. The Earth came out from dinosaur and monkeys and people. The evolution, how the evolution started using this genetic algorithm. So we are going to see this. So I'm not going to stress too much here. And the genetic algorithm has three main types. Okay, selection rules select the individuals called as parents, and the contributes as population. And we are going to see the selection is generally stochastic, and crossover rules. We are going to combine two parents to form children. And the mutation rules apply random changes to individual parents. Okay, so we are going to use that in genetic algorithm. So this was all about the KNN, guys. So we are going to go for the coding part now. Please focus. So why we are going to use this KNN, right? So let me open. So this is called as spider, guys. Spider Python, where we're gonna use all our codings. Okay, so we are gonna use this coding. I have run the code, guys. So you can see to increase my accuracy, I have used so many terminologies, guys. Okay, so let me show you. So this is my KNN, guys. Okay, this is my KNN. So what are the libraries I have been used? So I'm going to import NumPy as NP. Okay. So I'm going to import NumPy as NP, nothing but a library, NumPy for normal calculator, and I'm going to import pandas as PD, right? Which has data manipulation. I'm going to import math, OS. These are all the libraries, guys. These are all the libraries we have, and we're going to import that. Okay. So we have Seaborn as SNS. We are going to import light VGM, SKNM. So basically what we're going to do here using this KNN. So let me say you guys, this KNN, I'm going to use this robotics. It's going to find out as it is going on the floor, what floors it is going on tiles, it is going on the starboard, it is going on any other devices, or it is going on any sand road. Okay, it's going to classify that. So we are going to use KNN to classify to which the robot is evolving, where it is running. Okay, we are going to see that using this KNN. So I have given a data set for this. So I have run the data. So I'm going to explain what the data is made up of. Here you can see these are the libraries which I have imported, guys, to classify which type of data we have. So let's see. So you can see I have splitted my training test data. Okay. We know we have to split the data. Okay. So I have splitted the data using xtrain, xtest, and ytrain and ytest, the upcoming. So I have used on this. I'm going to print xtrain shape as xtrain.shape. So I'm going to use a train and test, guys. Splitting. The split methods for train and test data. And we're going to increase the accuracy if you want. So we are going to see what are the values we have. So here you can see I'm going to drop some columns which is not required for me, guys. So group by, I'm going to use group by, and I'm going to use series ID, reset, measurement number. I'm going to take a series ID, and you can see what is the correlation I have got. So this is my apps correlation, guys. So I'm going to print top absolute correlations. Okay. So as we move on, I'm going to see what all the TF methods we have used. So we have name change, we have feature engineering, okay, and we are going to see merge data sets, how we are going to merge the data set, okay, and how to train the surface. So basically, I said, guys, we have to train our model to recognize surface, right? So we're going to classify using this robotics how it is going to define. So basically, let me say it's going on tiles, how to classify that. Is a surface on that? It is going on sand road, okay? So basically, it is like that. And when we are going to move, we can see we have used what type of gradient we have. What type of test we have prepared? Label encoder. I'm going to use label encoder. I'm going to classify it, guys. I'm going to input light PGM as LGB. And I'm going to take this, okay? I'm going to split my train data into test data sets. So as I said, I have run the code, guys. Let me show you my data set. Okay. So we can see the data set we have was opening the data frame. So here you can see the indexes. So what all we have the indexes for this? We have linear acceleration, angular velocity, orientation. We have what is this acceleration is all about. Okay. So after that, we're going to see what are the fold, k-fold cross validation, the integer, what is that? Okay. And we are going to see what is basically we need. Okay. The splitter, the split, how we are going to split the data. See, you can see the accuracy is increasing, guys, randomly. See, the accuracy is increasing. How to increase the accuracy? We have seen. We have so many of data, guys. Okay. So you can see the splitter, the test index, and we are going to have X text and Y text. We're going to train our data set like that. And after that, we're going to get the plot, guys. See, this is my first plot. Let me expand and show it to you. Here you can see, as I said, we are going to see. So what is the data point we have, right? So basically we have like this is, so what is the angular velocity? What is the mean it's going to stand for? Okay, you can see the angular velocity, what is the mean? So how it's going to recognize the surface for orientation, right? So this is the plot which I have for the first plot, guys. And if I go for second, here you can see the angular velocity type. And this is my graph for this test. Okay. So here you can see what is the graph, the median of the KNN, what we have got the classification. You can see what is the classification. See the linear acceleration, angular velocity, orientation. So we are going to go for mean of variables for each group, guys. Okay. This is my acceleration of KNN, what I have got. Okay. This is my plot, which I have got, guys. Okay. So it is going to give us the value. So what is the mean of variables for each group? What is the angular velocity? What is the linear velocity? We are going to classify that, guys. So we are going to classify using KNN. Okay. So we have got the graph, and you can see I have used X-train data to prepare and merge. Okay. We are going to drop the hard tiles, guys. Don't need hard tiles for this. I'm going to drop the hard tiles, which is not important to me. I'm going to top the surface. I'm going to drop hard space. Okay. So as we can see, we have seen these data sets. Okay. So data sets is all about finding the surface, right? So it's going to find the surface. So what we have, it's going to give on which surface it's going to run. Basically, this KN is used for classification. Okay. And we have seen what are the libraries we have implemented, what are the plots we have got, what are the ideas we can implement using this KNN. We are going to go for angular velocity vector, Euclidean, linear regression, acceleration was velocity, feature engineer. So basically, this test and train data is very important, guys. Okay, test and train data. We need this test and train data to split our data where we can find our accuracy. Okay, you can see the axis which I have used. We are going to drop the train, the surface of the hard test. See, I said we're going to drop the hard test because it's going to represent 5% of the data set only, guys, 0.5%. Okay, and variables we're going to train drop surface of axis of 1. So why we are going to use this label encoder? So what is the purpose of this label encoder? One-hot encoder. One-hot encoder is nothing as basically 0 and 1. Okay. So as we have seen the data set which we have used and everything. So let's move on next, guys. So what is hyperparameter? Okay. If our accuracy is low, or if you want to increase our accuracy, we are going to use this hyperparameters. Okay. So you have to remember that why we are going to use this hyperparameter. If our accuracy is low, or if you want to increase our accuracy, we are going to go for hyperparameter. So after hyperparameter, we are going to go for label encoder. We are going to use the code which is important to us. Okay. You can see we are going to import light PGM as LGB. We are going to use splitter. We are going to use k-fold cross validation. We are going to use fold validation. We are going to use LGBM classifier. Okay. So after that, we are going to use what is this use of light PGM classifier. So what are the things we have to transform? What is the best score reached? So what is the prediction is our robot giving? Robotics Analytics is going to give us. Okay, and we're going to go for series ID where we have list of range. Okay, data set dot head is nothing but, guys, it is going to give me top 5 of the data set. Okay, and I'm going to split training data sets. You can see the train data set. I'm going to use this library from sklearn.model selection, import train test splits. And I'm going to see what is X-train, what is X-test, what is Y-train, what is Y-test. I'm going to split that. Okay, split that data. So this is all about the KNN, guys. So how we are going to use KNN. We have seen what is meant by KNN, how we are going to implement KNN, right? So the coding part is literally easy, guys. Nothing we are going to do. We are going to do for classification, where I'm going to use this classification to take the changes we have. Basically, we're going to see the classification where we have where it's going to take, where it's going to go for the classification. It's going to go for the roadmap, or it's going to go for any other surface. So basically, if there is hard tiles, we are going to drop that. Okay. So this k-fold cross validation is all about that KNN, and we are gonna go for train data. We are gonna use the CSV file of xtrain.csv, and we are gonna go for test data. We are gonna predict the data. We are gonna see what are the train shape we have, what is the test shape we have, what are the columns and ID. So if you are gonna ask me what is the columns and ID, you can see row ID, series ID, and we have a measurement number and group ID. Okay, so these all we have. So the measurement of the column ID we have here is for the robotic analytics is nothing but we have 5 IDs: row ID, series ID, measurement ID, and group ID. Okay, this is our columns. We are going to count the information for each column. So when we count each column, we are going to use train as null, and we're going to use is null thing. Okay, so after that, we are going to use group by function. So group by series of ID, we are going to use measurement number, and we are going to go for to get the tops of the correlation. Okay, and after that, we are going to see what are the correlations we have. Okay, and after that, we are going to use Euler's thing to get how the robotics is going to work. And we're going to go for the change, what we need. We are going to use the future engineering. We are going to write the code of orientation, linear acceleration, linear orientation. Okay. So these are things where we can use this. And after that, we can see what are the series ID we have, train surface and surfaces. Okay. So these are the variables we are going to use. Okay, and we're going to use what are the tests we have. we are going to import light BGM as BGM, and we are going to use what all the predictions we have. Okay, so you can see the data is running, guys, where we can predict our data set using this. So what all the accuracy we have got, right? This is how your data is going to run, guys. It's going to take time, as I have used some terminology to increase my accuracy of the robot. Okay, and after that, I'm going to go for an enumerate split, where I'm going to split the data which is not important to me, and I'm going to drop some hard tiles, and I'm going to ignore the errors of ignore, and in place I'm going to go with as true. I'm going to use the fit function, okay, where I can use this fit function to overtrain our data sets. I'm going to use the best score range with params, and I'm going to go for the list what we have. So this is how we are going to use KNN. So we have seen the surfaces of this KNN. So how it's going to recognize the surface, right? Which surface it's going to run. So we're going to ignore hard tiles. So this was all about KNN, guys, where we're going to classify and we're going to segregate our data. Okay. So basically we use KNN to segregate our data, and we're going to use that how to get our data which is very accurate. Okay. So this was all about KNN, guys. So we have seen robotic analytics in KNN. So this was all about day 4. Okay. So in day 5, we are going to see the K-means clustering, how we are going to apply K-means clustering, how we are going to use linear regression, what we are going to do in decision tree, and what other things we are able to implement, right, after decision tree. What are the things we have to implement after decision tree? We are going to use terminologies, we are going to use steps where we have to apply some codes. So this was all about day 4, guys. Okay, and it is done. So we have seen in day 1 what is the thing we are going to work on, what is robotics, what is introduction of that. And day 2 we have seen what are the agendas. And day 3 we have seen what is EDN pre-processing. And day 4 we have seen what is mean by KN. So this was all about day 4, guys. So thank you for attending. In case if you have missed any classes, you can watch my recorded videos. So how you're gonna get idea what we have done. Okay. Thank you, guys. Thank you for attending the session.